Hello, my name is Suyeon Park, a presenter of the paper on economic theory. The title of the paper is Collaborative Caching in Wireless Video Streaming Through Resource Auction. The presentation will be followed this order, such as the composition of the paper. In this paper, the authors address the dynamic user needs and related cache server resource problems that arise in caching system. With mobile users covered by two or more WSPs within one area, collaborative caching between cache servers deployed on different MSCs can be designed. For this reason, they propose a new mechanism which is a collaborative caching that improves the social welfare while guaranteeing both incentives and truthfulness. The system model of the mechanism is set in the following scenario. WSP-A and WSP-B deploy cache servers at their own MSCs, which are connected to base stations. A server in domain B only has a limited storage capacity. Um, with independent caching, requests to unavailable contents in B have to be relayed to remote servers. Um, the authors address this issue through collaborative testing, which can improve streaming quality by exploring cooperation between cache servers across various management domains and mitigate sudden request spikes in domains that occur frequently when popular channels are present. In addition, they apply VCG option to mitigate the self-isolation that each cache server has and to increase system-wide efficiency. In the process of auction to obtain bandwidth, the participants become cache servers. Each cache server acts as both a seller or bidder. Auctions are conducted when bidders need a certain amount of bandwidth from sellers to fulfill contents or to elevate the pressure on heavily loaded cache channels. The basic explanation of VCG auction is omitted from this presentation because it is covered by Professor's lecture. The virtual bidder which participate in the auction uses valuation function V to calculate the valuation of the benefit of receiving n bandwidth units. In video streaming system, the user streaming quality can be used to reveal the actual benefit or of receiving a certain amount of bandwidth units. The expression on the screen is used by independent caching. Gamma is an adjustable scaling parameter, and R is channel with streaming rate, and X means concurrent users, and alpha has between 0 and 1 value. In collaborative caching used in the paper, the expression is transmitted as follows. The valuation function reflects the streaming quality improvement over channel K by receiving n units of bandwidth from server J. The notation E represents the degradation of benefits due to the differentiation of coverage areas among different domains of server I and J. From the winner detection, each cache server J needs to determine the allocation of W after receiving bits from other servers. The circle of the equation represents the optimization variable in the formulation. The value omega means basic unit to be traded in VCG auction. In general, this problem is integer programming problem and NP hard. The truthfulness is no longer guaranteed in a VCG auction if the approximation algorithm is applied. The payment for bidder is calculated using the following expression. The asterisk denote the optimal solution to the winner detection problem. The implication implications of virtual payment are twofold. First one is an incentive to resource contributors, which incur cost in delivering content. And second one is the truthfulness of collaborative caching, which is guaranteed. As I said earlier, the conventional winner determination in the form of integer programming results in a high computational complexity. However, the valuation function in our proposed mechanisms leads to a polynomial time optimal allocation through the following theorems. Especially, the valuation function satisfies the downward sloping property in theorem 1 by the first order derivative. We can see the valuation monotypically increases with a growing number of provisioned bandwidth units. And the second order derivative is constantly smaller than zero, which indicates the valuation function satisfies the downward sloping property. Thus, the seller can then achieve the optimal solution to problem in polynomial time. The authors represent implementation issues considered in this system. The four issues are considered for the following reasons. Local resource allocation is used for the local content estimation, since the status of a local channel is always known to the respective WSP. The decision of W is also based on the variation function to optimize the performance. The decision of N is determined by the remaining budget in auctions. The cache server formulates an optimization problem that minimizes the number of requested units. Demands with higher valuations can be found through a local search in polymer time, and requests are therefore issued. This decision is made based on the external bandwidth availability and the content availability. Those cache servers with more available bandwidth, W, omega, are preferred to be selected. Finally, if the trade is performed in its time slot, the resource allocation is achieved with finer granular granularity, but excessive computational overhead. To mitigate such overhead, the trading result can be potentially used for a longer period of time. Furthermore, the main benefits of collaborative caching in wireless video streaming is the ability of requesting locally unavailable contents, which improves the storage utilization through resource multiplexing. For this reason, the limited cache storage should also be carefully utilized and without loss or of generality. Cache servers are required to keep full copies of video channels. Authors analyze the effectiveness of different cache storage strategies in independent caching mechanisms and collaborative caching mechanism into three main categories. Evaluation is based on a time-slotted simulator implemented using Python and follows the environment setting. The value of parameter beta and gamma lambda is set to 0.6 and 0.5. Due to the random initialization of each cache storage, the streaming quality of collaborative caching and independent caching stay stable at around 50% and 30% respectively. After the first storage update, the storing quality of independent caching increases to 40% as more bandwidth units are utilized for supporting channels with high valuation. However, the storing quality of collaborative caching does not explicitly increase since the resource auctions already fulfill the demands for those unavailable popular videos before the storage update. The rationale is that independent caching prefers to assign bandwidth resources to the most popular video to achieve a better overall performance. As such, only a smaller portion of videos can be satisfied by deployed cache servers. In comparison, the the diversified content exchange under collaborative caching and dedicated bandwidth resource in resource auctions could help maintain a higher cache hit ratio and relatively stable streaming quality. Mm, In the figure, in the left figure, um, it displays the impact of the portion of bandwidth resource that are allowed to be utilized by other WSPs. And the right one denotes the effect of parameter lambda in the storage update under different storage capacity settings. Mm, it can be observed that the storing quality is maximized when an adequate portion of bandwidth is allocated for other WSPs, and both excessive local and external bandwidth provisioning in collaborative caching cannot yield the maximal storing quality. The reason is that when beta is small, most of the content requests from other WSPs can be satisfied even with a low valuation of the bandwidth units. Um, the left figure suggests that we can properly design the beta to achieve better streaming quality in practical engineering. And from the figure right, we observe that a local demands first strategy is preferred when the storage capacity is limited in collaborative caching. the sensitivity the sensitivity of gamma decreases when the storage capacity is relatively abundant, since both locally preferred and socially preferred contents could be kept with a large storage space regardless of specific setting of lambda. Mm, Authors examine the overhead incurred by the proposed collaborative caching by analyzing the impact of the update interval of cache storage and that of bandwidth allocation. The result illustrates the trade-off between the streaming quality and the frequency of cache storage updates. It can be seen that the performance gap between the two mechanisms becomes more significant when the update interval gradually gets larger. This shows that independent caching has to frequently update its storage, which brings a higher cost associated with the cache replacement. In sharp contrast, the performance of collaborative caching remains stable despite specific cache update strategies. And um, we can analyze the trade-off between the storing quality and the update interval of bandwidth resource allocation. It shows that the overall streaming quality only slightly decrease along with an increase of the allocation update interval. This implies that in practice, it is feasible to reuse existing bandwidth allocation reserves, which further reduce the overhead of auction mechanism. Um, and the left figure plots the respective streaming quality of different WSPs in the simulation. It shows that the variation of streaming quality at WSPs exhibits a similar pattern over time. This demonstrates that the proposed resource auction can improve the social welfare by mutual assistance. The right figure plots the cumulative amount of received packets from other WSPs. It can be observed that the trends of all covers remains similar overall, which allows reflects the fairness of the collaborative casting mechanism. Um, in this paper, the authors propose a collaborative casting in wireless streaming service, and they solve the challenges of incentive and truthfulness of service WSPs using the collaborative mechanism that maximizes the service welfare in the context of VCC auctions. And they demonstrate that the performance of streaming systems can be significantly improved with maximized social welfare in auctions conducted by the collaborative casting mechanism. Thank you for listening.